The following video will introduce you to how to set up the VisualDOC Microsoft Excel interface, which will allow user to make use of Microsoft Excel spreadsheet to calculate responses as required during optimization process. Let's start with an example. Consider a rectangular box with two dividers. The objective is to minimize the use of material for making the box, that is, minimize the surface area of the box. Here, design variables are height, width, and depth of the box. It is subjected to constraint volume of the box should be greater than or equal to 2, where the volume of the box is given by height into width into depth of the box. Constraints on design variable for height, width, and depth of the box, lower bound is 0 and upper bound is 100. This example is available in VisualDOC Advanced Manual, where detailed steps required to solve the problem using VisualDOC are given. In this video, I will cover all those steps in detail. This is a simple example for demonstration. VisualDOC has a capability to solve extremely complex optimization problems. Now let's open VisualDOC. Click on the File button on the main menu bar. Select New Project. Select the folder where you want to save the project. Enter the name as Excel Interface. Click on New Project Database button. Now the next step is to create workflow. From component palette, add optimization component. Next, click on Excel component and add it inside optimization component, as this component is used to define analysis needed. Now add a stop block. Now select flowchart components from model tree panel and select Auto Connect All Models icon. This would connect all the components based on their order in model tree panel. Now click on Automatically Rearrange All Models icon and select Yes. Now next step is to set up the Excel component. Go to Component Editor tab. Select Excel component from model tree panel. Enter the variables and responses in the middle panel. For area and volume, select Output in Input-Output column. Initial value for design variables H, W, and D is 1. To allow data transfer between VisualDOC and Excel, user needs to provide the Excel information. In my Excel spreadsheet, the variables H, W, and D entries appear in B4, B5, and B6 cells respectively. For responses area and volume, entries appear in E4 and E5 cells respectively of spreadsheet 1. Thus, in middle panel of VisualDOC window, enter 1 for H, W, D, area, and volume in sheet column. For H, W, and D, enter 4, 5, and 6 respectively in the row column. For area and volume, enter 4 and 5 respectively in the row column. In the column labeled column for HWD, enter B. For area and volume, enter E. Note that in your Excel file, the entries can be located in different locations, so make sure that you are entering the data accordingly. In Excel file definition, make sure that relative to model directory option is selected for the file part type, as I have saved the VisualDOC model in the same location as that of Excel file. Now click on File icon and select your Excel file. It is very important to test the Excel component to ensure the interaction between Excel and VisualDOC. Before testing the Excel component, make sure that Microsoft Excel is closed. If Excel is open, Excel will not allow VisualDOC to read and write the data. Now push the test button. After successful execution, you will get a message under Standard Messages tab. Next step is to create data transfer needed for the optimization component. Now go to Data Linker tab. Select Optimization in Model Tree panel. select Optimization in the middle panel. Make sure that Auto Link checkbox is selected. Now click on Automatically Add Data to Selected Model icon. This will add the corresponding links for the data transfer between optimization and the analysis. Next, we will set up the optimization component. Go to Component Editor tab. Select Optimization in the Model Tree panel. For variables h, w, and d, lower bound is 0 and upper bound is 100. For area, select the checkbox under Objective column and deselect the checkbox under Constraint column. Make sure that Minimize option is selected in the Goal column. For Constraint volume, enter the lower bound as 2. I will be using modified method of feasible direction, which is default gradient-based optimization method in VisualDOC. Now, I will create two simulation monitors to monitor the best objective and to monitor the values of three design variables. Go to Simulation Monitors tab, add two optimization history monitors. Now select second optimization history monitor and click on Add Sample to Selected Monitor icon 2 times to add 2 more samples. I am adding 2 more samples so that I can plot 2 more set of data in the same monitor. Now click on Expand Hierarchy icon below the Flowchart Components panel as well as the List of Monitors panel. Drag the best objective under Simulation Parameters and drop it on the X1 axis of the first monitor. Similarly, for second monitor, drag the data H under Optimization and drop it on the X1 axis of the sample 1. Drag the data W and drop it on the X1 axis of sample 2. Drag the data D under Optimization and drop it on the X1 axis of sample 3. To activate the defined monitors, click on Enable All Monitors icon. Now click on Validate icon. Our complete model is valid. Now click on Run icon to execute optimization. To view the defined monitors, click on View Monitors tab in the message area. Now click on Tile All Frames icon. This will automatically rearrange all monitors. For both optimization history monitor, x-axis represents number of iterations. Total number of iterations are 5. For first optimization history monitor, y-axis represents best objective value for each iteration. For second optimization history monitor, y-axis represents value of design variables h, w, and d for each iteration. For iteration 0, there is constraint violation. Red cross indicates constraint violation. To check which constraint is violated, go to Post-Processing tab. Select Optimization in the Model Tree panel. Click on Generate Summary Report icon. Scroll down to iteration 0. Thus, constraint on volume is violated. For iteration 1, value of area is 12.68. After 5 iterations, it has been reduced to 11.99, satisfying all constraints. To view the optimum results, go to Component Editor tab. Select Optimization in the Model Tree panel. The table displayed in the middle panel has optimum values in the optimum column. This completes the demo. I hope it has helped you to get familiar with VisualDOC Microsoft Excel interface. If you would like to learn more, I invite you to check other videos about VisualDOC. For additional information, please visit our website at www.vrand.com or email us at visualdoc.support@vrand.com. Thanks for watching.